Hi, so this video is going to discuss some application problems from section 3.3, and we'll start with number 41. That is found on page 196 of your textbook. A ball is thrown directly upward from a height of 6 feet with an initial velocity of 20 feet per second. The function s of t equals negative 16t squared plus 20t plus 6 gives the height of the ball in feet t seconds after it has been thrown. Determine the time at which the ball reaches its maximum height and find the maximum height. So for starters, what we'll do is we'll just look at the graph, and then we'll talk about how we can gather pieces of information from the equation, even if we had not looked at the graph. So we'll go to y equals and we'll key in our function. We're going to replace the t's with x's, so negative 16 x squared plus 20x plus 6, and we'll look at the graph. I'm going to do zoom 0 to fit the graph to the screen. Okay, so our graph looks like this. It's very clear from the shape of the graph. The graph is concave downward, opening downward, and therefore we will have a maximum at the vertex. So let's discuss how to find those pieces of information. So I'm going to go back to the original screen. And we had s of t equals negative 16t plus 20t plus 6. We know our leading coefficient is a negative 16, which is why we have a concave down or upside down u. So we'll have the top of the hill, so we'll have a maximum. All right, so if we want to find the maximum, we're going to find our vertex. And again, just like we did when I was using the calculator, I'm going to replace all of these t's with x's. Okay, just writing it here so you'll know what I'm doing. All right, so we have x equals negative b divided by 2a. It's where we'll have our x coordinate of the vertex or axis of symmetry. So x is going to equal negative 20 divided by 2 times negative 16. And again, we got these pieces of information from the standard form and from identifying our A, B, and C. All right, so we'll just do the math to simplify. We have negative 20 divided by negative 32. So x equals positive 20 30 seconds. And we can go ahead and express this. We can write it in decimal form. So that equals 0.625. Now keep in mind we replaced the t's with the x, so keep in mind that this represents our time. This is our time. So at this time, our ball will reach its maximum height. So our graph looked like a U. Here's our maximum height, okay, or our maximum. So we have this represented by time, comma, height, right? So the time at which it reaches its maximum height is what we just found, 0.625, and it's measured in seconds. Okay, and if we want to find the actual height that the ball has reached at this unit of time, we need to substitute in the 0.625 back into our function. Okay, so I'm going to write it down here in a different color. So we're going to substitute in t or x, depending on which way you're thinking about it. 0.625 seconds, and we're just going to substitute it in. So we'll have negative 16 times 0.625 squared plus 20 times 0.625 plus 6. And those are 6 2/5s. All right, and so now we'll just do the math. We'll let the calculator do the computation for us. And I'll bring up the calculator just to review with you how you can key this in. So I'm going to go back to the home screen. I'm going to show you a couple of things since we're looking at the calculator. So I'm just going to type it in the regular way that we would normally do to compute negative 16 times 0.625 squared plus 20 times 0.625, and then we had a plus 6. Enter. And so the maximum height that this ball reaches is 12.25 feet, and it reaches that height after 0.625 seconds have elapsed or passed. Okay? But while we're here, I wanted to show you something that's kind of cool. Since we already had our function in for our y equals, remember we talked about before how you can make the calculator show you your table and your graph at the same time. Just reviewing some things with you. So we'll press mode. We'll go down and we'll say, hey, I want you to split my screen to show me graph table. Okay. And we have our graph and our table on the same screen. Well, another thing we can do is we can say, all right, I see you've made the table for me. So the calculator has automatically computed the y or the output values, these heights, based on these measurements of time that are represented by the x values. Okay, so x is your time, y is your height. All right, well, what we can do is we can say, hey, I want to tell you which value of x I'm looking for, and I want you to compute it for me. So to do that, we would come over here and press our second and then our window button for table set. And instead of it being on auto, we are going to tell it, hey, I want you to now be on ask auto. I want you to ask me what value I want you to substitute in for x. Okay, so then we did that. We're going to press enter so that ask is darkened or highlighted, and then we're going to come back over here. Now our table is empty because it's waiting for you to tell it which values you want to find. So we found that after 0.625 seconds, we have our maximum. That's our time. We want to find the height that goes with that. I'm going to tell the calculator, hey, plug in 0.625, press enter, and it automatically computes the 12.25 output in the table. All right, so that's just another way you can use the calculator to your advantage. Alrighty, so let's go back. Let's switch screens again. Go back to the screen where we just were looking. Let's write our answer. We got 12.25 feet. So we found our maximum. Okay, so we answered the question. We determined the time and we determined the maximum height. All right, let's look at another one. Let's look at number 46. Okay, so number 46 says a fourth grade class decides to enclose a rectangular garden using the side of the school as one side of the rectangle, all right? And then it says, what is the maximum area that the class can enclose using 32 feet of the fence? What should the dimensions of the garden be in order to yield this area? Alrighty, so we have this drawing whereby we have like the school right here, and then they have this garden, okay? And the amount of fencing that we have to enclose the garden is 32 feet. So the perimeter that we're using is 32 feet. That's all we have. Well, we have a rectangle. My picture doesn't look like one, but that's what I was trying to draw. All right, so we have this rectangle. Well, we know in a rectangle that opposite sides are equal. So we know that these two sides are going to be equal, right? We don't have to try to enclose the part of the garden that is against the school. So we don't know how long this side of the garden is, so we'll just say that that is x. Okay. So how much fence do we have left to enclose on either one of these other sides? We have 32 minus x left to use. And we have to split it equally on this side and that side. Okay, because those sides, one can't be longer than the other, because if it is, then we would not have a rectangle. All right, so it has to be split perfectly evenly in half. So the lengths of those other sides would be found by simply saying 32 minus x divided by 2. Dividing it in half. All right, so now I'm going to come and just kind of redraw our picture with all of our information that we just found included on it. Okay, so that's 32 minus x over 2. This is x. And again, this is all in feet, by the way. And then 32 minus x over 2. All right, and so now we want to answer the question. It says, what is the maximum area that can enclose, the class can enclose using 32 feet of fencing? All right, so the maximum area that we have a rectangle. Area of a rectangle is length times width. Okay, so one side is x, the other side is 32 minus x over 2. So if we multiply those, we'll actually find a formula for the area of this rectangle. So we'll do x times 32 minus x all over 2. And that's how we're going to find our area. Okay? So whenever we multiply fractions, we multiply straight across. This x has an invisible denominator of 1, so we'll just multiply straight across. So we'll have x times 32, x times negative x. So that will give us 32x minus x squared all over 2. Okay? So what do we have? We have our area. We can say a of x, because our area, it won't let me write. So our area, something's going on, it won't let me write. So we have area. I'll call whoever it is back, okay, because I'm making a video. Okay, so we have area. So we have area. Oh my gosh, my marker has really stopped working. Let's see. What's going on? Will it right here? No. Okay, marker. Marker. Let's try it again. Right. All right, I'm going to have to continue this video in a second. Let me reboot my computer and see if I can't get this marker to connect. So stay tuned for part 2.